Hello guys, welcome to the lecture on differential equations of higher order. In the previous lectures, we learned about homogeneous differential equations and non-homogeneous differential equation. And also we learned about how to solve homogeneous differential equations by finding the complementary functions. And also we learned about how to solve non-homogeneous differential equations by the concept of particular integral. And also we discussed about one of the particular integral type, that is polynomial equations. So in this lecture I'm going to discuss briefly about the particular integral type exponential function. So when the function is exponential, we'll see how to solve the differential equations here. So the particular integral of the type, I'm taking exponential function. So if the RHS part of the differential equation contains exponentials like this, we have to use this concept. So here the finding the complementary function will be same as we did in the homogeneous differential equations, but the finding the particular integral will change here. So the formula for particular integral is exponential function divided by f of d function. So where we know that f of d is nothing but a differential operators. So here the first step is we have to replace this f of d function by a. So we have to replace all the d terms by a in the equation to get a particular integral, and it should satisfy the condition f of a should not be equal to 0. Okay, the first step is replace this d by x coefficient. So we are for example, if the function is e power 2x is there, we have to replace all the d terms by 2 like that. Okay, and with the condition f of a is not equal to 0. Suppose this f of a will be equal to 0, we'll see what we should do. So suppose if f of a is equal to 0, so after replacing d by x coefficient, the denominator leads to 0, the answer will become infinity. But particular integral cannot be infinity. So to avoid this situation, we have to differentiate the denominator and we have to multiply x for the numerator. And again replace all the d terms by a after differentiation, and with the condition f dash of a is not equal to 0. Suppose if you got the f dash of a is equal to 0, differentiate again the denominator and multiply one more x for the numerator. So I will get x square e power x by f double dash of d. So here also we have to replace all the d terms by a. With the condition, same condition, f double dash of a is not equal to 0. So now we will see how to simplify few equations. The problem is like this: d square minus a square into y e power ax is equal to e power ax minus e power ax is the equation here. The first step is we have to find the complementary function. So for the complementary function, already we know that we have to replace all the d terms by m. So if I replace d terms by m, I will get the equation like m square minus a square is equal to 0. So this is the auxiliary equation, I got it here. So after getting auxiliary equation, we have to find the roots for m. So I got m is equal to plus or minus a. On simplifying this equation, I got the roots like this. Since here the roots are plus a and minus a, roots are real and distinct, the complementary function will be yc is equal to c1 e power ax plus c2 e power minus ax. So complementary function we got it. The next step is we have to find the particular integral. So for the particular integral, I am having two functions here, that is one is e power ax, one more is e power minus ax. So I am taking this function in the numerator divided by d square minus a square, the operator equation I am taking here, and split the equation. Since the function having two equations here, one is e power x, one more is e power minus ax, I am going to expand it. I will get e power ax by d square minus a square minus e power minus ax by d square minus a square. So now to find the particular integral, we have to replace all the d terms by x coefficient from the exponential. So in the first equation, I can replace d by a, and in the second equation also I can replace d by minus a. So if I replace d by a and d by minus a for both the equations, the denominator leads to 0. So since here the denominator is leading to 0, I am going to differentiate the denominator with respect to d. So differentiating d square, I got 2d, constant a square will become 0. Same thing for the next equation also, differentiating d square will become 2d and minus a square will become 0, and we have to multiply x for the numerator. So I got the equation like x e power ax divided by 2d minus x e power minus ax by 2d. So again same thing, to find the particular integral I am going to replace d by x coefficient, that is a here and a in the next, minus a in the next equation. So I got x e power ax by 2a minus x e power minus ax by minus 2a. So from both the equation we can observe that the common factor is x by 2a. So I can take x by 2a common factor, I will get e power ax plus e power minus ax, I will get it. So and this e power ax plus e power minus ax, I am going to, and along with that x by 2a I am going to replace in the y equation. So the final y solution will be y is equal to yc plus yp. So it is combination of both complementary functions as well as the particular integral. So I got the solution like c1 e power ax plus c2 e power minus ax plus x by 2a e power ax plus x by 2a e power minus ax is a solution for the given differential equation. So we will see one more example related to the exponential equations. So the equation is like this: d square plus 2d plus 1 into y is equal to e power minus ax. So obviously it is a non-homogeneous differential equation of the first type. So first make the auxiliary equation. So if I replace d by m, I will get m square plus 2m plus 1 is equal to 0 is an auxiliary equation. On solving m square plus 2m plus 1 is equal to 0, I will get the roots like m is equal to minus 1 comma minus 1. So here we can observe that the roots are real and equal. So and the roots are repeating here. So if the roots are repeating, the complementary function will be yc is equal to c1 plus c2x into e power minus ax. So we got the complementary function here. So next we have to find the particular integral. So take the formula. So the formula is yp is equal to the given function divided by operator equation, that is d square plus 2d plus 1. So here we can observe that. So here x coefficient is minus 1 in the numerator. I am going to replace all the d terms by minus 1. So if I replace d is equal to minus 1, I will get 1 square minus 2 plus 1 in the denominator, and it will become 0. So the whole yp will become infinity. So already I told that if the denominator will become 0, we have to differentiate the denominator, multiply x for the numerator. So in the next step, I multiplied x for the numerator, differentiating the denominator. So differentiating d square, I got 2d. Differentiating 2d, I got 2. So I got 2d plus 2. So again I am going to replace d is equal to minus 1. I got minus 2 plus 2. It is again 0. So again we have to multiply x for the numerator and differentiate the denominator. So if I multiply x for the numerator, I'll get x square into e power minus x. Differentiating 2d plus 2 with respect to d, I will get 2 and the constant will become 0. So I got the equation like yp is equal to x square e power minus x by 2. So now the final solution will be combining both yc and yp. So y is equal to, I got yc plus yp, c1 plus c2x e power minus x plus x square e power minus x divided by 2. This is a solution for the given non-homogeneous differential equation of the type 1. One more example. So the problem is like this: d square y by dx square minus 4y is equal to cos hyperbolic 2x minus 1 plus 3 power x. So here first we have to identify this function belongs to which type. So we know that, so the cos hyperbolic function will be a combination of exponential. So I can expand the cos hyperbolic function like e power x plus e power minus x by 2. So here the function is like cos hyperbolic 2x minus 1. So I can write like e power 2x minus 1 plus e power minus of 2x minus 1 divided by 2. and this 3 power x can be expanded like e power log 3 into x. So now, so same thing as usual, make the auxiliary equation first, replacing all d terms by m. So the auxiliary equation will be m square minus 4 is equal to 0. I got it. On expanding this, I got m is equal to 2 comma minus 2 are the roots. So the roots are here, real and distinct. The complementary function will be yc is equal to c1 e power 2x plus c2 e power minus 2x. I got it. So now we will see about yp. So yp is equal to cos hyperbolic 2x minus 1 plus 3 power x divided by d square minus 4. So as I told that, I am going to expanding that cos hyperbolic function. I got the equation like 1 by 2 into e power 2x minus 1 divided by the differential operator plus e power minus 2x minus 1 divided by the differential operator and plus 3 power x divided by d square minus 4. So I'm going to simplify this like p1 plus p2 plus p3. So I'm taking the first function as p1, the second function as p2 and the third function as p3. I'm going to solve all these three equations individually. So let me solve p1 first. So the p1 equation will be given like 1 by 2 e power 2x minus 1 by d square minus 1. So here we can observe that in the numerator the exponential contains x coefficient is 2. So replacing d by 2 I got 2 square minus 4, denominator will become 0. So as I told that if the denominator is 0, multiply x for the numerator, differentiate the denominator. So I got 1 by 2 x e power 2x minus 1 divided by 2d. So it will become, on replacing d by 2 now, I will get 1 by 8 or x by 8 e power 2x minus 1. So since here 2d is there, if I replace d is equal to 2, it will become 4. Already 1 by 2 is there, so it will become x by 8 e power 2x minus 1. Similarly p2 also. 1 by 2 e power minus of 2x minus 1 divided by d square minus 4. So if I replace d square by minus 2, I will get the equation like denominator will become 0. Because the d square is equal to, it will become plus 4 only. So 4 minus 4 will become 0. The denominator will become 0 here. So again same thing. So if it is 0, we have to multiply x for the numerator, differentiating the denominator. I will get the equation like 1 by 2 x e power minus of 2x minus 1 by 2d. Now replacing d is equal to minus 2, I will get 1 by 2 x e power minus of 2x minus 1 divided by minus 4. It will be equal to minus x by 8 e power minus of 2x minus 1. So this is for p2. So now we will see how to expand p3. So p3 is given by 3 power x by d square minus 4. So since it is not in the exponential form, I am going to convert 3 power x in terms of exponential form like this, e power log x log 3 whole power x. So since here the x coefficient is log 3, so I will take the e power log 3x by d square minus 4, replacing d by log 3, I will get e power log 3x by log 3 whole square minus 4 or 3 power x divided by log 3 whole square minus 4. So next, so now combining this complete yp, so I will get p1 plus p2 plus p3. So add all this p1 plus p2 plus p3 values, so we will get yp. And to get the complete solution, I am going to write y is equal to yc plus yp, combining the complementary function with particular integral, will get the complete solution here. So the solution will be like this, c1 e power 2x plus c2 e power minus 2x plus x by 4 into sine hyperbolic 2x minus 1. So this one is obtained by, this function is obtained by adding p1 plus p2 and taking x by 4 common factor, will get sine hyperbolic 2x minus 1 here, and plus 3 power x by log 3 whole square minus 4. This is the solution for the given differential equation. So one more problem is like this here, d square y by dx square minus 6 dy by dx plus 25y is equal to 3 e power 2x plus sin x plus x. Take this one for assignment and solve it. The solution will be like this here, y is equal to e power 3x c1 cos 4x plus c2 sin 4x plus e power 2x by 17 plus 4 sin x plus cos x by 102 plus 1 by 625 25x plus 6. Thank you.